This month I have 3 algebra problems for you. My strategy for each of these is going to be the same. I'm going to focus on whatever makes the problem complicated. Figure out how to deal with it. Now here's our first equation. We have square root of x plus 7 equals 2 plus the square root of x. We have to find x. Well, what makes this complicated are these square roots. Square roots, if these were gone, I'd be a lot happier. So let's try to make them go away. How do we make square roots go away? We square things to make square roots go away. So what I'm going to do here is I'm going to square both sides of the equation, because if two quantities are equal, then their squares are equal. Now we have to be careful because this road doesn't necessarily go the other direction. Right? Just because we have two squares that are equal doesn't mean the original things we squared are the same. Because, for example, if we take -2 and square that, we get the same thing as when we square 2. So when we finish this problem, when we start with this, where we're squaring both sides, we're going to get another equation that must be true, but it doesn't necessarily have to go the other direction. So we have to check our answers at the end to make sure we haven't introduced any extra extraneous solutions. But we'll come back to that in a minute. First, we're going to go ahead and square this out. Well, you square this, we're going to have x plus 7 whenever this quantity is non-negative. You know, if x is -8, then we've got a problem. Because if you stick -8 in there, you've got a big problem, because now we're taking the square root of a negative number. We don't want to do that. So this tells us right away that any solutions that we get out of this approach, where x is less than -7, they're going to be a problem. So we'll remember that. We'll come back to it later. Now when we square this side out, what are we going to do here? I'm going to go ahead and write this out in more detail. Because this is what we mean when we say square this side. We don't just mean square the 2 and square the square root of x, because there's going to be a few extra terms, and we're about to see those. And what's going to happen here when we multiply this out is I'm going to have 2 times 2. That's going to give me 4. I'm going to have 2 times the square root of x, and then I'm going to have another 2 times the square root of x. That's going to give me 4 times the square root of x. And then I have the square root of x times the square root of x, and that's going to give me x whenever x is non-negative. Now, the interesting thing here is pay attention to this middle term. You can't forget that middle term. So look at what happened when we went from here to here. We get the square of the first term. We get the square of the last term. And we have 2 times the product of these 2 terms that comes from here and here. Now, this is an equation that's a lot simpler than this because a lot of things cancel. I can subtract x from both sides, they go away. I can subtract 4 from both sides, and I end up with 3 equals 4 times the square root of x. Now I divide by 4, and I have 3/4 equals the square root of x. So that tells me that x is 9/16. Just square the 3/4. Now again, we have to go back and check, because we squared the equation at the beginning. We're going to have to go back and check this, stick the 9/16 in here and see if it works. So I put the 9/16 in there. I add the 7 to 9/16. 7 times 16, that's 112/16. I add the 9, I get 121/16 on the left side. And then over here I have 2 plus 3/4. And sure enough, 121/16, take the square root of that, you get 11/4. 2 plus 3/4. In both cases, you get 11/4. So we're happy with our 9/16 answer. We're on to the next problem. Okay, we're given that x plus 1 over x is 3, and we want x to the 4th plus 1 over x to the 4th. Well, maybe we can just find x. We're going to get rid of the complication over here. I'm going to multiply both sides by x, get rid of that fraction, and I'm going to have x squared plus 1 equals 3x. Well, I'm going to bring the 3x over. X squared minus 3x plus 1 equals 0. And I can't factor that. I could complete the square, I could use a quadratic formula, but I'm not excited about that because I'll find x. But x is going to be some complicated thing, and then I'm going to have to raise it to the 4th power. Then I'm going to have to take the reciprocal of that. No fun at all. So I'll remember this. I'll come back to this if I get stuck. So I'm not going to completely cross it out, but I am going to start over again and try to find an easier way to get to this, because I don't actually have to find x. It doesn't ask me for x. It asks me for x to the 4th plus 1 over x to the 4th. We're going to go after that instead. Well, how do I get from x up to x to the 4th? I could raise this to the fourth, but that doesn't look like fun. I can square it. We just saw how to square these things pretty quickly, right? I can start off by going x plus 1 over x. We can square that, and that's going to equal 3 squared. And we know how to square this expression. We just did something just like it. We square the first term, we get x squared. We have 2 times the product of these two terms. Well, x times 1 over x is just 1, and I'm going to have 2 of those. Again, if we wrote this out as 2 binomials, I'd have x times 1 over x. It's 1 over x times x. 2 of these. That's where this 2 pops up. And we have the square of the last term, 1 over x squared. And this all equals 9. I can subtract the 2, move that over there, and I have x squared plus 1 over x squared equals 7. So I've made a step. I went from x plus 1 over x to x squared plus 1 over x squared. Made some progress, still not quite there. Now, one of the things I like to do in problems when I make a little progress but don't quite get to the end is I look for a way to do that same trick again. All right, here we went from here to here by squaring. We're going to go from x squared plus 1 over x squared to x to the fourth plus 1 over the x to the fourth by squaring again. X squared squared gives us the x to the fourth. And once again, we have 2 times the product of these. The product of these is 1 again. We have multiply that by 2. Then we have the square of the last term. Gives us 1 over x to the fourth. And this all equals 7 squared is 49. And there we go. We subtracted 2 from both sides. And we made it all the way up to x to the fourth plus 1 over x to the fourth without ever having to find x. There's our answer. On to the next problem. Now here we've got, again, another wacky set of equations, a over 4 minus a, b over 5 minus b, c over 7 minus c equals 3. We want a plus b plus c. Now we could just cover these up and say, hey, I've just got an equation right here for c. Multiply both sides by 7 minus c, get a linear equation, solve, and that'll work. That'll work just fine. You can find a, you can find b, you can find c. Hope you don't make any algebra mistakes, and then add them all up. It's not very sporting. We're going to try to solve all these equations at once. All right, we're going to try to get rid of the complication here. And the complication is these expressions in the denominator. These are complicated denominators. I don't like complicated things in denominators. I like simple things in denominators or nothing in denominators. So, well, we can get the complicated stuff out of the denominators here by just taking the reciprocal of everything. If all these expressions are equal and a, b, and c aren't 0, and clearly they're not 0, we can just flip everything over and write this as 4 minus a over a equals 5 minus b over b. All we're doing is taking the reciprocal of each of these expressions. Now, I like this a lot because what's going on here, I made my denominators nice and easy to deal with. And if I take this expression right here and I split it up, I have 4 over a minus a over a. Well, that's just minus 1. And this is a much easier expression to deal with than this stuff up here. So all I'm doing is simplifying away my complications. Now I just add 1 to everything. And I've got 4 over a is equal to 5 over b is equal to 7 over c. Adding 1 to this as well gives us 4/3. Well, now my simple stuff is in the numerators. These are nice numbers instead of variables, so I'm going to flip it over again. Flip this over again, and I have a over 4 equals b over 5 equals c over 7 equals 3/4. And this is very easy to solve for a, b, and c. We multiply by 4, multiply by 5, multiply by 7 in each case. So we have a is 4 times 3/4. Now I'm not going to multiply that out just yet, because I'm looking downfield a little bit. I'm looking downfield. I'm seeing I really want this sum, a plus b plus c. Don't really care what a is, don't care what b is, don't care what c is, just care about their sum. B is 5 times 3/4. C is 7 times 3/4. So now I see that when I'm summing here, I'm going to get the factor. I'm going to have a plus b plus c is equal to 4 plus 5 plus 7. All of that times 3/4. This is 16. 16 divided by 4 is 4. 4 times 3 gives us our sum. It's 12. And we're all done.